Hello, everybody. Today, we're going to talk about pixel streaming and what radiologists can learn from gamers. My name is Charles Morris. I am the Director of Enterprise Imaging here at AGFA HealthCare. I have been in the imaging arena for about 19 years. So I have been on this digital journey with our radiology community in North America and globally. And today I am joined by Dr. Lindsay Burton, and I'll let her introduce herself at this point.
Hi, everyone. Thanks for joining our webinar. I'm really excited to be here. I'm the physician executive for health tech at Amazon Web Services, or AWS. I'm also a practicing radiologist, board certified, fellowship trained in musculoskeletal imaging, and I've worked in academics, private practice, and teleradiology. So I understand your world very well. This is my first time actually talking about gaming and radiology, and it's funny because for years I've been using a gaming mouse, I've been using a gaming keyboard just because they're more ergonomic and it makes my life easier as a radiologist with preset buttons and tasks. So Charles, what inspired you to pick this as our topic for today?
We have been internally educating our own staff about streaming technology. It's a technology that we're adopting at AGFA HealthCare. And we have used a lot of different types of analogies to try to explain the technology in ways that normal people would understand without having to be an engineer. And there's a few analogies. Some of them are like Netflix uses streaming to get videos to us, and we had mentioned that some gaming services. So when we were asking internally what type of a webinar or seminar we would be interesting for radiologists, this topic got pulled because everybody found it very interesting. So hopefully today we will get to go a little deeper as to how this gigantic gaming community is allowing us in medical imaging to increase our technology and make the lives of our radiologists much, much better as we move into the future.
We look forward to that, Charles. So yeah, let's dive in.
I'm going to turn my camera off so that we can move on with our presentation. So as a radiologist, what if you could display studies faster, work from a greater variety of locations, gain more device independence, and deal less with the hardware aspect of your day-to-day work, which we know can be onerous. Let's think about these as we go through our general presentation today. So I'd like to do a little bit of history. Some radiologists are familiar with this, others aren't, so we'll do a quick little background. The backbone of our industry, as you may well know, is DICOM. DICOM was invented around 1985, and something I think that is interesting is that the first internet was created around 1986, and it was on a 56K modems back in those days. And modems were very, very noisy, and networks were very slow, and they had lots of challenges with communication of data. And DICOM was really invented, believe it or not, for kind of this environment. And that traditional DICOM standard, for the most part, as we get data out of our modalities, largely hasn't changed since these days. And so DICOM is not the most efficient mechanism to move data around for high-speed access. We'll talk how that crosses with the gaming environment here shortly. But there's a couple technical terms that I'd like to start off with on our presentation. One is the concept of bandwidth. And bandwidth is really just the maximum amount of data that might be able to be transferred over a connection at any given time. The FCC defines broadband as a minimum of 25 megabit. And I think most of the United States, I think it's high 80s, has bandwidth, broadband capability these days. And hopefully you have a bit more than this at your own home. Latency is actually the concept of a delay that it takes to transmit that amount of information over a network. So it's partly physics of how much time it physically takes to transfer, plus equipment latency or time delay is latency. So bandwidth and latency are the big villains in speed and performance for radiology. There's also this thing called jitter that talks about how stable a network is, and things like packet loss if we're on very old or slow kind of networks that don't have a good transmission rate. And then last but not least is this concept of network congestion. So if we have 100 radiologists, they're all reading on the same network and all requesting image data at the same time, we can actually fill the entire network up and have no more capacity to send images, which ultimately slows down our ability to display and cycle through studies through the day. Now, these challenges kind of are exacerbated with this underlying transfer methodology, because today we have larger and larger data sets coming from our modalities, our daily workloads. The expectations are that radiologists need to perform more procedures in a given shift. The pixel density from those same modalities is going up over time. The CT density that we had 15 years ago is not the same density that we have today. It is more and more prevalent that radiologists are working remotely and not just at the office, if you will. And so when they are working remotely, a lot of times radiologists are, of course, working from home, and those home networks are a bit challenging because they're typically not as fast as the network at the office. So how do we kind of overcome this and still provide very high speed to radiologists kind of wherever they are? So part of the math behind this is that an average DICOM file is going to be somewhere between 50 megabytes and 2 gigabytes to download, and you're going to have to download the current study as well as any number of priors between 2, 3, 4, 5, depending on your preferences. And so you start to get a lot of data that needs to be downloaded. Now, at the office, those are gigabyte networks, and we have very, very low latency. And so DICOM actually works pretty well on this type of a network. But as soon as we get to networks with more latency, DICOM starts to slow down because it has this concept called an ACK. And an ACK is, it's just simply an acknowledgement that a part of the study has been received and you're allowed to send the next part of the study. Well, every single time an ACK is sent back and forth across the network, the latency consumes the capacity of the network, and therefore it feels like the network slows down the further we go, and that's just because we can't use as much of the bandwidth. So DICOM is sensitive to latency. Now, at this point, I'd like to turn it over to Dr. Lindsay, and she can carry on with.
Sure, thanks, Charles. So Charles just talked about challenges in medical imaging, and as radiologists, we're very familiar with most, if not all, of these challenges. So how can cloud help solve the challenges that we see in medical imaging? I'll give you a few examples. So cloud-based PACS and VNA, these offer increased speed and reliability. What this does for us as radiologists is it translates to faster speed to get both your current images and your prior images. And it also provides high availability, enabling you to interpret images around the country, even around the world. There's no downtime for updates, so you're not, stopping your work for a couple hours for a software update. So updates happen immediately. And also cloud provides the compute so that you can run AI and ML models at scale. An example of imaging in the cloud. This is AGFA's Enterprise Imaging Vendor Neutral Archive, or VNA, and their viewer, which are both hosted on AWS. This enables easy access to the patient's entire imaging record, including not only diagnostic images from radiology, but also any procedures that the patient had on the floor, any of those images as well. And most importantly to discuss is, for us at AWS, security is job zero. We take data privacy very seriously, and we have security teams monitoring for threats 24/7, 365 days a year. In addition, we have over 131 HIPAA eligible services. We also have GDPR eligible services, and we have 137 high trust certified services. So we understand healthcare and we know how to keep healthcare workloads very secure.
Thanks. So next, let's start talking about this cross between radiology and gaming. So let's talk a little bit about gaming. I don't think that many of us are squarely in the gamer category, but we have a lot to learn from the gaming community. So let's go through that a little bit. So of course, there's a huge history of gaming. It goes all the way back to the mid 1970s. And the interesting thing is that console-based gaming is all about local rendering hardware, which is not unlike the types of workstations that most of the radiologists have to deal with today, where they have a video card underneath their desktop and a big, workstation sitting there that does all the work for them. These types of gaming consoles are just that. There's a GPU or a video card hiding inside these, and they do all of the rendering of the video game on the TV. Now, some companies, this happens to be an example from a company called Unreal Engine, and there's numerous of these. I happen to pick Unreal Engine to talk about today because they're some of the pioneers of this technology, where they would have a game that is running on a server, and they can effectively stream that game live to multiple endpoint devices. And of course, the only thing that's actually sent to these devices is the pixels of what is being seen in the game, but the game itself is never on these endpoint devices. Now that's really great because that allows me to run a high-powered engine on the server, something much larger than what I can have under my desk, at my practice, because of course servers can get very, very large. So I get the performance of these extremely high-end, servers without needing all of that hardware. Now, so the idea here is that the term pixel streaming comes from the fact that we're moving the pixels from the server to the client as a stream. And this might be something like we would see, kind of in the Netflix world, where I poke a button and there's a server, in the cloud somewhere, and it streams the video to me, but I don't actually ever own the video. I'm using the pixels from the server. Makes it easy. Now, gaming is very, very competitive, and so performance of how quickly we can generate the image on my client device is important. In the gaming world, where my computer thinks a target might be versus where a server thinks the target is, can be the difference between a win or a loss in a game. Now, that maps directly back to radiologists, because in the world of streaming, we want to make sure that there's no cursor lag, so that where the server thinks that I'm pointing at on the screen is actually where it is. And the latency plays into this. Now, certain types of streaming technologies, such as AGFAs, take this into account. It's a really important aspect of getting that real-time user feedback. Now, Amazon Corporation has a service called Luna, and in fact, this is a pixel streaming gaming service. Now, that can run on a regular Fire TV stick, which is very, very, lightweight. It's just, it has a little HDMI plug. You plug it in the back of your television, and you have a gaming console. And there are thousands of titles that are available in the cloud, and you can poke any of those games and just play it as though you have a console in your living room, but you don't, which is great. Now, why would companies like Amazon? They're not the only company doing cloud-based streaming, but why would companies like Amazon want to do this? Well, gaming is a huge industry, and luckily for us in the diagnostic imaging world, industries like this have spent an enormous amount of money and time building base technologies that allow high-speed, high-performance streaming, and we get to benefit from early advances that that these vendors have invested in. Ultimately, Amazon is interested in doing this because it's easy for consumers to just have a controller and not have to worry about buying the latest, greatest deck from XYZ company. They just get access to the games. It's really nice. So how does the architecture look? Well, Luna is a service that runs in AWS. They have a bunch of video cards or graphic processing units, GPUs that are in the cloud. I, as a consumer, will log in on a mobile device or a streaming device in my house, and when I poke the button, it enables the GPU to render the game, and it streams it to my house, and effectively I get remote access to the game. So in the old world, I had a console and the game was sent to me and I plugged it in at my house. In this world, the gamer is sent to the cloud and their experience actually happens there. So let's bring this back to imaging and let's talk a little bit about how this streaming technology could potentially assist radiologists. So I'd like to ask Dr. Lindsay a question, which is, in which ways does performance or speed, or what I'll call geographic flexibility of you being able to move around, assist a radiologist in her day-to-day work?
Hey, Charles. Yeah, right now what's happening with imaging is, there's too many studies to read. There's a shortage of radiologists, and also there's a lot of consolidation going around with hospitals and private practices. And so a lot of times we're reading from multiple different sites at a time. We might be sitting at one site and reading from other sites. Sometimes we're reading from home and covering multiple different sites. And so that's where the power of cloud really helps, since we can read from anywhere and still be able to interpret studies quickly and have great access.
Excellent. Thank you very much.
So you may be wondering about the reach of cloud. Well, AWS has the largest global infrastructure footprint of any cloud provider, with 32 launched regions and 102 availability zones, and we continue to expand. The AWS global infrastructure enables companies like AGFA to be extremely flexible and take advantage of near infinite scalability of the cloud.
Excellent. Thank you very much. So what I'd like to talk about next is kind of the generations of PACS rendering technology and the progress our industry has made in providing more and more performant environments for radiologists. Gen 1 PACS systems actually run on DICOM itself. In fact, AGFA was one of the first, if not the first, organization to produce a commercial PACS system over 25 years ago. Now, these systems were very onerous to deal with, right? We had a dedicated workstation, there was local hardware in that GPU, we had a physically installed client, and the DICOM was downloaded directly from a PACS server to our workstation in order to work on it. Now, in the second generation, it looked a lot like that first generation, except now we had some more proprietary download capabilities that improved our download performance, and the actual data was still downloaded to a local workstation and rendered locally on a local video card, but the performance went up, so that was good. Generation 3, we started to enter the web type of world, and now our proprietary downloads started to move more towards JPEG or PNG files, which are kind of internet standards. And you can see that the size of our workstation got smaller, and which is great, right? But we still have a GPU hiding in there, so everything is downloaded and still locally rendered, even though the technology is more efficient. Now, we got to our first generation streaming technology. Streaming's been around a little while, but it hasn't quite matured yet. You'll see in a second. And so in this world, we finally got to server-side rendering or pixel streaming, And now we kind of can start to use that on almost any type of workstation. It's server rendered, pixel streamed, but a lot of those first generations still required an installable client that had to be managed and had to be upgraded and that sort of thing. And there were still GPUs living in the cloud, right, or in the source server on a network somewhere, right? Now, onto the 5th generation, which is kind of where we are at AGFA HealthCare, is that we are still on any workstation at this point in time. It's a pure web client. It's not an installable client. Server rendered, pixel streamed, but now our servers do not require those expensive GPUs. It's just done with regular CPU technology, which is really great because it's lower cost than all of the technologies that we had before. And I can have an extremely lightweight solution that runs on something like even like a lightweight laptop without any performance loss. So how does that technology look? Well, it looks a lot like the Luna design that I showed earlier, where Luna had a bunch of GPUs, but this type of streaming service just uses CPUs in the cloud. You log into a mobile device or any workstation or any web client, and you as a radiologist are effectively taken to the images versus the images being sent to you. That's really the big difference, right? We're in this technology, you'll be taken to the images. Now, another big difference is before on those DICOM technologies, we really need a really thick network, 1,000 megabit for a gigabit network, and we had to have really fast or really low latency, meaning distance to the server, because DICOM is not very efficient. In this new world, we have very low or just basic broadband and regular general internet latency that you'd find at most homes in the US these days is all you really need to make this work just as fast or faster, because again, we have bigger servers here than what you can put under your desk in order to produce a very high speed display. And the question is what does 50 milliseconds look like in distance, right? So 50 milliseconds in an unimpeded fiber connection is about 2,600 miles away, right? So this Gen 5 streaming technology, anywhere that is within that 50 millisecond latency window as far as distance, a radiologist could sit anywhere in this area of the United States and access a server that happens to be where I live here in North Texas, and you'll get the same performance as though you're sitting on a local network. So you could be in Chicago and get the same performance as sitting in North Dallas. You could be in Florida and get the same performance as North Dallas. So streaming is a game changer for our industry because it gives us freedom and it gives us that high-end server performance speed of getting those images to our desktop and allowing us to cycle through our work list very, very quickly. Now, how does it go about doing that? Well, streaming's smart. In this PET-CT, if I manipulated just this viewport and that transition to changes in these two viewports, the streaming client is only going to send pixels that are actually affected in these viewports. It's not going to resend data to me that's already been rendered and is not being manipulated at this time. So it's very selective in what it sends to the client, as opposed to having to send the whole data set every single time. So it's very, very efficient, and they're for very performant on these lower bandwidth, just general broadband connections. And the general question always is, well, what about MAMO and DBT? Absolutely, because the interesting thing about streaming technology is that the source data does not matter as much anymore. When I have a display, and that is a 5 megapixel display, I'm only downloading 5 megapixels worth of data. Where the source may be multiple gigabytes of data, I only ever need to fill my screen with 5 megapixels worth of data, which is a lot less than the source. Even though through manipulation I have access to the entire source data, I'm actually consuming a much smaller piece of that that's available for display. So when we say that streaming technology can really be accessed anywhere, we have a great little video of one of our developers' cars. This is in his car, and you can see how the streaming technology can really be accessed. We don't recommend that everybody use it in this fashion, but you can actually see the capability of how well this actually works within basically any browser device. This one happens to be in his car, but it could certainly be on a tablet or on a phone or any device that's less than a full-blown workstation. So I guess I'll try to summarize. Why should you as a radiologist be interested in what gamers are doing? Pixel streaming is a transformative technology for us, and ultimately it can assist you in both speed and flexibility. We're not tied to a desk anymore. We don't have to be tied to a desk. So high-speed image display on basic broadband. We eliminate the complexity of dedicated workstations and dedicated VPNs because this is secure HTTP-based web access for imagery. And Pixel streaming is a cloud-aligned service, so we can take all the horsepower, all the network, all that security that AWS has and deliver streaming through those services. It's a really great partnership. We really appreciate being an AWS partner, and I would like to turn it back over to Dr. Lindsay for closing comments.
Hey, thanks so much for listening into our webinar. Charles and I are available for any questions you have. Feel free to email us, and we'll also stay online for you guys to ask questions now.
Ask if you are visiting RSNA and you are curious about streaming technology and would like to learn some more about streaming technology. You can certainly find AGFA HealthCare at booth number 2552. So make a note of it. Come by and learn a little bit more about streaming at RSNA. Thank you so much.
Great. Thank you both so much for that presentation. So at this time, we're going to jump into the Q&A. If you haven't already, please go ahead and put your questions in the Q&A box. If we run short on time and we don't get to your question today, someone will be in touch with you to follow up. Charles, I see we've already had several questions come into the Q&A, so I'm going to pass it back to you to start moderating through those.
Let's see here. We have a number of questions that are coming in. Oh boy, there's a lot of questions. Let's see. Let me try to work through a few of these and find a couple that are really good. I have a cable modem at home. I know that is not as good as fiber. Will it affect streaming performance? That's actually a really good question because there are different types of internet broadband connections, and some of them are, I'll say, private, and some of them are shared. Cable modems are typically a shared service, so depending on what other data and traffic is moving across your cable modem, you may run into network congestion. When we talked about those original, I think 6 or 7 concepts that cause performance, network congestion is one of those ones that we try to avoid. And cable modems are, as you've stated, a little not quite as good as fiber, because fiber does switching and cable modems share network. So that's one of these days you'll end up with fiber, hopefully. Let's see here. Quite a few others. The VPN I currently use significantly slows down my work. How does a VPN affect streaming, or does streaming require a VPN? Well, there's not really a straightforward answer to this, so I'll come at it from a couple different angles. depending on your organization, you may have to use a VPN, depending on their security requirements. But strictly speaking, this newest 5th generation streaming technology works over secure HTTP, or for those technically oriented, port 443. And so it is natively encrypted. So we don't need VPN, strictly speaking, for the imaging component of this. But VPNs are a lot of times organizationally imposed. Technology is starting to allow us to get away from those. So hopefully your organization can take that into consideration as the industry moves towards streaming. Let's see here. So I think that this is a good question for you, Dr. Lindsay, is how does AWS support the healthcare industry and medical imaging in general?
Sure. So we do a lot in the healthcare industry. Not only do we support hospitals, healthcare organizations, even I think it's like 85% of healthcare startups also run on AWS. So we're doing a lot with the healthcare industry. And some examples of this, we have like cloud-based electronic health records. We're also working with imaging vendors to host their cloud-based packs. And, as you see with AGFA, cloud-based VNA, and then we're also working to accelerate medical research and image sharing as well.
Thank you, Lindsay. Gosh, there's so many questions. How has image quality changed over the 5 generations of PACS? I think that there's context somewhere in here that I'm going to have to answer it multiple ways. I think that from a modality basis, certainly images, we've gained more resolution in images out of our modalities over these 5 generations. The pixel density of an average study has more than quadrupled over that period of time. So the source resolution has gone up. I'll say for our industry, across all vendors, the diagnostic imaging PACS vendors have done a very good job of trying to keep up with displaying those accurately to the radiologist. Now, we've used all sorts of different types of techniques as an industry in order to do that. As I explained, some of them are data format changes. Some vendors use compression, but I think in general, we still at AGFA, we like to use the term full fidelity. We strive to represent the study as it came off of the modality to the radiologist with no changes. And so I think as an industry, we've done a pretty good job at that. Let's see here. For a Gen 5 solution, is the PACS server still living on premise, or can we have this living in the cloud, say on AWS? That's a great question, because as I kind of concluded in this presentation, streaming is cloud aligned. Streaming in it to itself is not a cloud service. So at least with our technology, I can't speak for everybody in the industry, our technology for streaming can be either cloud-based or on-prem. Now, of course, the whole industry is moving fairly quickly towards cloud. That's one of the reasons why we asked AWS to present with us here today as our partner. Ultimately, that's your choice. So you have the flexibility to have it either on-prem or in cloud. Let's see here. How does screen size affect streaming performance? That's actually a really great question at the heart of streaming, because as we talked about, the concept of streaming is that it fills my screen with pixels that are, I'll say, borrowed from the server, right? We're not downloading images in the traditional sense. And so if I have a 2 megapixel, a 4 megapixel, or a 6 megapixel display, more pixels to fill means the higher resolution monitors actually have, if you fill all the pixels, will take more time to fill all of them. right? It's not to say that the viewport that you are working in is going to necessarily be larger or smaller than a viewport on a lower density display. But if you completely refresh a full 6 megapixel monitor versus a 2, it will take longer on the 6 megapixel monitor. Let's see here. This has to do with security. So they're in the world of using cloud, would there need to be a HIPAA or a BAA agreement with Amazon as well as AGFA? It depends on how you set your service up. If the service is directly through AGFA, then the BAA is with AGFA. If you choose to use your tenancy within AWS and run AGFA software within your tenancy, then you need a BAA with both organizations. Let's see here. Are there applications for the acquisition side of imaging? That's actually a really great question that we didn't really focus on in today's presentation. We were really focusing on the radiologists today, but of course there, medical imaging and is a whole cadre of staff that help us get those images that we present to the radiologists. And absolutely, the same acquisition or the same streaming technology is used for acquisition and quality control of images in the same way that we just talked about here for display to a radiologist. Yeah, I think that's pretty short there. Let's see here. What other technology? Actually, I think this is another one I think that's targeted towards you, Dr. Lindsay, is what are some technologies you are excited about right now?
Okay, there's a lot that I'm excited about, but I would say that the most exciting thing right now is AI and machine learning. And I know as radiologists, we've been hearing about AI and machine learning for, at least the past 5 years in the sense of helping with diagnosis, but we're seeing more and more applications of AI where you don't even need to have experience building models before. It's anyone of any skill level can start to build ML models. And then I think now with generative AI, possibilities are endless of what we're going to see going forward, whether it's conversational AI, helping us with reporting. So I think there's going to be a lot of exciting developments in the future. So it's still technology that I'm excited about now.
Thank you.
Sure.
Let's see here. Sorry, it's quite a list. I know we can't get through every question today. But here's two that are actually related. Is AGFA offering streaming technology today? The answer is yes. And then the question from a different attendee is, how can I get a demonstration of the streaming technology? As I said at the end of the presentation, you can certainly, if you're attending RSNA, you can certainly see us there. If you're not, then you can reach out to me at the email address that I had quickly showed. I think that we can put my contact information in the chat for all the attendees. Let's see here. I think that, yeah, there's some very, very, very technical questions, which I don't think, I'll answer the extremely technical questions direct in chat. I don't think that they're probably very good for a very, very broad audience. What about integration with AI providers? This is in relation to what you were just talking about, Dr. Lindsay, yeah, so that is actually one of the benefits of streaming technology being cloud aligned and having our AI partners working with us in the cloud is that the workflow starts to become very, very transparent to either radiologists or clinicians that want to utilize different various types of AI. Some of those are clinical AI, some of those are workflow triage, prioritization AI, And all of that is co-aligned in the cloud, works really well in the cloud together. That's why we and many other vendors are moving towards cloud to get more synergies there. Let's see here. Let's see, can you, oh yeah, we will reshare the email address. I see that somebody's asked for that. Here's an interesting one. Talks a little bit more about network and streaming, which is more on our topic today. I have Starlink at home. Well, will streaming work with Starlink? And actually, we've tested our client with Starlink. Our client works really well with Starlink because it fits squarely within that broadband requirement. We've demonstrated on much lower quality networks, and even in a pinch in a very poor network, streaming technology can give you access to fairly high resolution, I should say original source resolution images. It just takes a little bit longer to fill those pixels. So I want to work with our moderators and ask a little bit about how much time we have left today.
Yeah, Charles. So I think if you have one more question you want to take, otherwise I think we'll go ahead and wrap up at that point.
Yeah. So here's a great question, which I think is a cross between both cloud and streaming technology answers. So I like it. I'll answer it. And the question is, what happens when the number of users increases? I assume there's a cap at which the server cannot process the images effectively. Well, this is where streaming and cloud really are very good bedfellows, because within the cloud, cloud has this concept called elasticity. And what it allows us to do is dynamically scale the number of serviceable units within the cloud. So in the morning, there may be a couple radiologists online, but by 9:30, we have 50 radiologists online. The servers can, within a cloud environment, can dynamically scale to support more and more users. This is how all the major streaming services, we had mentioned Netflix and others, it's how all those services function, and one of the really great benefits of cloud providers like AWS.
Great. Thank you so much, Charles and Dr. Burton. So that concludes all the time we have for today. I will be putting Charles' email in the chat, so if there's any follow-up, you can reach him there. Thank you, everyone, for joining, and we hope you have a great rest of your day.